What is the universe at its most fundamental level? When you peel back the layers of stars, galaxies, and atoms, what is actually left? This is the driving inquiry that has defined my entire path in the field of physics. After decades of exploration, I believe we are finally standing on the threshold of a definitive answer. But it is an answer that defies almost every common intuition we hold about reality. I remember my early years growing up in the Bronx, long before I ever dreamed of becoming a theoretical physicist. Back then, while I was working as a plumber, the world seemed tangible and straightforward. I viewed the universe as a collection of stuff, solid matter and flowing energy, existing within a vast empty container called space and time. It was a mechanical, intuitive picture of particles bouncing around in an arena. However, after a lifetime spent wrestling with the mathematical paradoxes of quantum mechanics, the mysteries of black holes, the complexities of string theory, and the revelations of the holographic principle, my perspective has been utterly transformed. The universe is not what most of us think it is. It isn't a collection of objects sitting inside a box of space-time. It is something significantly more abstract, more mysterious, and infinitely more elegant. At its deepest, most irreducible foundation, the universe is quantum information. Before we dive into what that means, let's dissect what the universe is not. If you find this exploration of the deep fabric of reality fascinating, make sure to subscribe and hit the notification bell so you never miss a deep dive into the secrets of the cosmos. Deconstructing the illusion of stuff. First, we must acknowledge that the universe is not primarily made of matter. To our eyes, matter is everywhere. Rocks, trees, the device you are using right now. But quantum field theory tells us a different story. In that framework, matter is not fundamental. It is an emergent property. An electron is not a tiny solid sphere. It is a localized excitation of a broader electron field. And what are these fields? They aren't physical substances. They are mathematical assignments of values to points in space-time. They are abstractions. When you look at the quantum state of a field, you are looking at a vector in an infinite dimensional Hilbert space. Matter is simply a high-level description of how these abstract quantum fields are configured. Furthermore, the universe is not primarily made of energy. Energy is undeniably vital. It is conserved. It dictates how systems change, and it drives the dynamics of the world. But energy is a property of a quantum state, not a substance in its own right. Mathematically, the energy of a system is the expectation value of a Hamiltonian operator acting on a quantum state. It is a piece of information about the state, not the fundamental bedrock of existence. Even space-time itself, the four-dimensional fabric Einstein described where space and time are woven together, is not the bottom floor. For years, my work on the holographic principle has suggested that space-time is emergent. It arises from something deeper. We see this clearly in the ADS-CFT correspondence, where a quantum theory without gravity or space-time living on a boundary can generate a full curved space-time in its interior. Space-time is a derived concept, a convenient way to describe the underlying data. The universe as a quantum state. If matter, energy, and space-time are all emergent, then what is the fundamental reality? My answer is this: whispers. The universe is a quantum state. Specifically, it is a single particular vector in an unimaginably vast Hilbert space, evolving according to the precise laws of quantum mechanics. Everything we perceive, particles, forces, gravity, and even the flow of time, emerges from the correlations within this state. The quantum state is the only thing that is truly real. Everything else is just a specific way of describing different facets of that state. In quantum mechanics, a system's state is represented by a wave function. This wave function is the ultimate repository of information. It dictates the probabilities of every possible measurement outcome. For a single atom, it's a simple wave function. For the entire universe, it is a functional on an infinite number of field configurations. It contains the data for everything that has happened, everything that is happening, and every potentiality that could ever occur. Curious. The universe is quantum information, and everything we experience is simply a way of organizing and describing that information. When we talk about information in physics, we aren't just talking about books or digital files. We are talking about the answers to the most basic questions. How many yes-no decisions do you need to make to fully define a system? This is measured in bits. While a classical system's information is straightforward, a quantum system's information is more complex due to superposition. But the core idea remains. Information measures the degrees of freedom available to a system. The holographic boundary. One of the most startling realizations in modern physics is that the universe has a finite limit on its information. This insight comes directly from the study of black holes. Jacob Bekenstein discovered that a black hole's entropy, its information content, is proportional to the surface area of its event horizon, not its internal volume. The holographic principle expands this to the entire universe. It suggests that the maximum information any region can hold is defined by its boundary. Because our universe has a cosmological horizon due to dark energy and accelerating expansion, our observable universe is a finite quantum system. The Hilbert space is massive, but it is bounded. If you are enjoying this breakdown of how quantum information defines our reality, excited, please consider sharing this with someone who loves thinking about the big questions of existence. This leads to a staggering conclusion. We are living in a hologram. If the information of our three-dimensional world is actually stored on a distant two-dimensional boundary, the cosmological horizon, then our 3D experience is a projection. The real universe is the data on that surface, and we are the holographic manifestations of that data. The ADS-CFT correspondence provides the mathematical proof for this. It shows that a boundary theory, a quantum field theory with no gravity, can perfectly describe a bulk interior, a universe with gravity and extra dimensions. The boundary is fundamental. The interior is the emergent hologram. The laws of information processing. If the universe is information, then the laws of physics are essentially laws of information processing. Einstein's equations, Maxwell's equations, and the Standard Model are all emergent laws. They describe the behavior of the output of the HE hologram. But at the fundamental level, the laws are about how quantum states evolve and how entanglement grows. In the AD-CFT model, these are the laws of conformal field theory. In our actual universe, curious, we are still searching for the exact code, but we know it must be a unified principle of quantum information. This is the theory of everything that physicists have long sought. Excited. It isn't just a list of all particles. It's a single principle that shows how all of physics is a consequence of quantum information dynamics. This raises a massive question. Why is the universe in this specific quantum state? Why not another? We don't have the full answer yet. Some point to the anthropic principle, that we observe this state because it's the only one that allows for observers like us. Others suggest a multiverse where every possible state exists. But I suspect there is a deeper principle, perhaps a requirement of maximum symmetry or simplicity that selects our specific state. This is one of the greatest remaining challenges in theoretical physics. The role of the observer and the Big Bang. What about us? If the universe is a quantum state, do we need observers to make it real through measurement? I don't believe so. The collapse of the wave function is likely an illusion caused by our limited perspective. At the fundamental level, the universal quantum state evolves smoothly and unitarily. E is no collapse. Pause. We see collapse only because we are inside the system, looking at a small piece of it while being entangled with the rest. We are not separate from the universe observing it from the outside. We are patterns of information within the state itself. We are configurations of data capable of processing other data, storing memories, and making predictions. This also changes how we view the Big Bang. Traditionally, we think of the Big Bang as the start of time. But if space-time is emergent, the quantum state itself might be timeless. The Big Bang isn't the beginning of the state, it's the point where the emergent space-time description begins to make sense. Looking before the Big Bang is like looking under a rug. It's the point where the classical carpet of space-time is woven from the quantum threads of the underlying state. From strings to computation. Whether you look through the lens of string theory or loop quantum gravity, the destination is the same. In string theory, the universe is the quantum state of vibrating strings, where space-time emerges from their configurations. In loop quantum gravity, you start with quantized geometry. Both paths lead back to the idea that the classical world is a derived reality. In a very literal sense, the universe is a quantum computation. The laws of physics are the algorithms. The quantum state is the program, and the map